Hello and welcome. Thank you for joining us. This is Build Real-Time Application Experiences with Serverless WebSockets, GraphQL, and AWS AppSync's Enhanced Subscription Filtering. My name is Ed Lima, and I'm a Senior Product Manager in the AWS AppSync team. So here's what we're going to talk about today. We start by quickly leveling up on GraphQL as a technology and how AWS AppSync leverages GraphQL to provide a powerful and flexible serverless API solution. We have a quick recap on the features we launched recently. After that, we get to the main topic of this session and talk about real-time application experiences. We then go through our brand new filtering and invalidation capabilities in detail, following up with use cases and how customers are using AppSync real-time capabilities at scale in production to engage with their own customers and enhance their user experience. Finally, we have a quick demo. So let's get started. So what is GraphQL? Let's start with traditional APIs or application programming interfaces. With traditional APIs, multiple endpoints are exposed to a client application, web or mobile, or even an internal service. These endpoints can access the same data source with different access patterns and requirements. In this example, you use 3 different databases, for instance. Imagine one for products, one for orders, and one for inventory details, if we are talking about an e-commerce application. With traditional APIs, loading the data is done sequentially. First, I need to access my first endpoint to retrieve some data. So I got data about products, but I only need to know a specific product identifier and its description. The client application has to manually pick and choose the fields in a JSON payload and discard the rest of the data. This is called overfetching. So I pass the product ID I retrieved from the first endpoint to the second endpoint in order to get some more data about orders that a given product is part of. Now I have data about orders and products, so I need to call a third endpoint to check my inventory. With traditional APIs, I had to make 3 API calls because I was either overfetching or underfetching data for each call. So it was I had to make more network calls to get all the data I needed. So what if I could get all the data with a single API call without overfetching or underfetching? And this is what GraphQL can do for us. Let's see how it works. With GraphQL, I have a single API endpoint exposed to all clients, and I only need to make a single API call. The client defines the data it needs in a query, and the GraphQL engine itself contacts all the data sources to request the data. Data sources then send a response to the GraphQL engine. The engine then constructs a customized JSON payload with all the data, including relationships. For instance, an order can have many products. The client then receives all data it requested, nothing more and nothing less, without overfetching or underfetching in a single network call. GraphQL is a query language for APIs and a runtime to fulfill those queries. It's completely unrelated to graph databases, as data is not persisted in the GraphQL layer. GraphQL is expressed as a declarative language for requesting data from your application backend. It uses a type system that allows you to understand data requirements and get meaningful error messages, making it easier to use and prototype. There are 3 types of GraphQL operations: queries to read data, mutations to modify or write data, and subscriptions. Subscriptions are linked to mutations and allow to send real-time notifications to subscribed clients whenever data is changed by a mutation. In blue here, that's what we call a selection set. The selection set represents a collection of fields defined to be returned by a GraphQL operation. The ability to define selection sets is a powerful feature of GraphQL. The client defines the data it needs. For instance, I can define my selection set with specific fields like an ID, data, the total of an order and the shipping estimate in a mutation. However, subscribed clients just need the ID, the order total, and the shipping estimate. They're not interested in the order date. No need to pick and choose fields from the static JSON payload in the client code. The response is dynamically generated by the GraphQL backend according to what the client defines. So what's the best way to use GraphQL on AWS? Well, you could run a GraphQL server, but servers are so 2014, aren't they? With AWS AppSync, you can build scalable and robust applications over the GraphQL with both real-time and offline capabilities. Best of all, no servers to worry about. AppSync allows to power applications with the right data from one or more data sources at global scale. It simplifies application development by letting you create a flexible API to securely access, manipulate, and combine data from one or more data sources. That can be databases or other APIs. To get started, you need to model and define your data in a type GraphQL schema. The data model in the schema tells API consumers what data can be exposed to authorized clients, with automatically generated API documentation. As the API can be defined with a simple and understandable type schema, it allows you to better organize and understand your data and the data flow between different downstream components of your API. GraphQL has a built-in compute or runtime component where developers can customize their own business logic directly at the API layer. These components are called resolvers, and they provide the logical glue between the data defined in the GraphQL schema and the data in the actual data sources. Using resolvers, you can map an operation or even a single field of a type defined in the schema with a specific data source, which allows you to retrieve data for different fields in the different data sources with a single API call. They're called resolvers because they are built-in functions in GraphQL that resolve types or fields defined in the GraphQL schema with the data in the data sources. Then we have the data sources in your AWS account, where the data is actually stored. So these are the main components in AppSync API: the GraphQL schema, the resolvers, and the data sources. Let's take a look at this specific scenario, an e-commerce system. Imagine there are different services in your application backend accessible via different technologies. User data is stored in a highly scalable NoSQL table, orders are accessed to a REST API, the current inventory stock is checked to a Lambda function, and price information is in the SQL database. Usually, client applications would have to make 4 or more different calls to each one of those services exposed to different API endpoints to get the data they needed, increasing the complexity on the client side. In order to get the data, I'd have to make at least, again, 4 network calls, and most likely overfetch or underfetch data, as different data sources would send an entire payload I might not need. With GraphQL and AppSync, you can access all the data from a single endpoint with a single network call. So AppSync GraphQL APIs combine the data from all those different services into a single payload the client defines, allowing to fetch only the data required for a client defined in the GraphQL selection set. Data is retrieved from multiple data sources automatically for me, and those data sources can be anything: SQL, NoSQL, HTTP, it doesn't matter. GraphQL is agnostic, so you can use the best tool and technology for the job in your backend. The client just sees a single constructed payload receiving user profile data from Dynamo, order details from the API gateway, as well as seamlessly injecting specific fields of inventory availability and price from data, and price data from Lambda and Aurora. All with a single network call and from a single API endpoint, abstracting all the backend complexity. Front-end or API consumer teams can add new features or applications without waiting for a specific backend team to implement new APIs. Since GraphQL is self-documented, it's easy for front-end developers to learn what data is available from a single unified GraphQL API endpoint. So now you're all experts in GraphQL and AppSync. Let's just have a really quick recap on some exciting features we released in the past 6 months. You can now use custom domain names to access GraphQL endpoints and the real-time endpoint of an AppSync API. Developers can have better batching when using Lambda resolvers and configure the maximum batching size to a size of up to 100, 2000, instead of the previous fixed default of 5. Perfect solution if you have to deal with the N+1 problem. We created a new extension that allows you to keep the managed API caching in AppSync always fresh. So each time data is modified with a GraphQL mutation, just that specific item can be evicted from the cache. Great for performance and lower latency use cases. You can also define directly in the AppSync additional custom headers sent to clients upon a response from an API call. We recently released some new VTL utilities, so you can generate case-sortable unique identifiers now in AppSync automatically. And also you can send a string of object from the resolver directly to CloudWatch logs, which is great to troubleshoot and debug a GraphQL resolver code. And finally, we have enhanced filtering for subscriptions, and that's the focus of our talk today. We're going to take a look a little bit more in depth about the new feature. AppSync customers are building all sorts of applications: enterprise, mobile web, IoT apps, accessing GraphQL APIs powered by AppSync to interact with different data sources in an AWS account. Universal APIs are used to consolidate and access data from multiple microservices, offline apps to provide access to synchronize local data when network connections are unreliable, and real-time applications to provide an engaging experience to users who need to access data as it happens. In this session, we'll focus on real-time. So what is real-time and why it's important for modern applications? With real-time, there's someone or something sending or publishing some data. It can be a user, backend event, or a service. It can be anything. Then there are interested parties, which are subscribers who want to receive updates about something they're interested in subscribe to. Maybe a chat group message, an order status, latest scores of an NBA game, a table available in a restaurant, and more. In order to be useful, users want to receive these updates as they happen. What's the point if the game I'm watching finished 2 hours ago and I only received the results of the game after I already know them? I want to know game stats right after my favorite player scores. This update should be sent to me automatically as a user. I don't want to keep refreshing a page or looking for updates myself. I have better things to do with my time. No one wants to be like a kid in a car trip asking, "Are we there yet?" every 2 minutes. Users receive the data they are looking for, and they don't need to look for it themselves. In order to be flexible, a real-time solution should enable direct one-to-one messages, or broadcasting to a select group of users, or even a wide audience of users fanning out messages to thousands of millions of subscribers. Which means filtering is a very important capability. If I'm a baseball fan, I want to receive notifications about baseball, not about the Cricket World Cup or soccer. Real-time applications are becoming increasingly popular in the new digital economy. It's being used as an important capability for different industries and use cases. For instance, delivering interactive learning experiences like multi-user classrooms, power engaging virtual events with interactive real-time features, deliver global real-time experiences to keep fans informed, engaged, and entertained, deliver fast, personalized fintech data in real time to mobile and web applications, power interactive gaming experiences that are wicked fast and utterly reliable, asset tracking, live transit updates, race-critical diagnostics, and more. Much more. And why it's so important. We're constantly multitasking and working on different devices, laptop, phone, tablets. There are lots of things going on, and users want to receive only important and pertinent information they need without worrying about what they don't need. We're all busy. Unless your application push information to users, they might not engage with it, and maybe they will forget it eventually. If you want to remain competitive, you must keep your user base engaged. Real-time is becoming a hard requirement for modern applications, but there's a problem. It's not easy to implement the infrastructure to support a proper user experience for your customers. In order to do it properly, to support your business, you need fleets of WebSockets and PubSub servers and a big team of engineers to manage the whole infrastructure. As your business grows, you need to think about implementing a properly distributed architecture with high availability, automatically scaling up or down according to demand, not to mention decent performance to provide data with low latency. Then your user base grows from tens to hundreds to thousands. The concurrent WebSocket connections to multiple devices need to be managed accordingly, with proper broadcasting and fan-out support so data gets to your users at the same time. All of that considering reliability, security, consistency, infrastructure management, patching, operations. The list keeps going on and on. Good news is that AppSync got you covered. You don't need to worry about this big list. We take care of infrastructure management, scalability, security, performance, and more. Real-time data, connection, scalability, fan-out, and broadcasting are all handled by the service, allowing you to focus on your application business use cases and requirements instead of dealing with the complex infrastructure to manage WebSockets connections at scale. In one of our tests with our WebSockets engine a couple of years ago, when we released the new pure WebSockets engine, we managed to effortlessly reach 10 million active WebSocket connections in AppSync with plenty of room to scale to much more. AppSync takes advantage of GraphQL subscriptions to perform real-time operations by pushing data to clients that choose to listen to specific events from the backend. This means that you can easily and effortlessly make any supported data source in AWS AppSync real-time, with connection management handled automatically between the client and the service. A backend service can easily broadcast data to connected clients, or clients can send data to other clients, depending on the use case. Whenever a client invokes a GraphQL subscription operation, a secure WebSocket connection is automatically established and managed by AWS AppSync, and it will remain constantly connected to your backend, allowing users to receive real-time data from any supported AppSync data source. And how does it work in practice? After authorized clients make a subscription call linked to a specific mutation, a WebSocket connection is established for 24 hours, providing a secure channel between the client and AppSync. Clients can be subscribed to multiple mutations, and the related subscriptions are all shared the same WebSocket channel. In this example, we have a single DynamoDB table, but it would work the same with any supported AppSync data source or multiple data sources. GraphQL subscriptions are invoked in response to a mutation or change in data. In other words, when data is modified via GraphQL mutation operation, AppSync notifies subscribers of that data change on successful completion of the mutation. In short, a mutation publishes data which is sent to clients subscribe to it following a publish subscribe or a pub/sub pattern. Here we have a client executing a mutation, for instance, create order or create message or update comment or delete task. It reaches their single GraphQL endpoint in AppSync. AppSync then performs authorization checks and executes any business logic defined in the GraphQL resolver. Then send a request to DynamoDB to create an item in the table. After the data is saved to the data source, AppSync automatically broadcasts the data to all connected clients. Each client can have different selection sets defined. For instance, a client might just need an ID, while other clients define an ID and a description, which means clients just receive the data they need. A backend process, for instance, sent by SNS or SQS or Event Bridge, Step Functions, AWS IoT, or any microservice in your architecture can invoke a Lambda function that executes a mutation against AppSync. Usually, backend processes in Lambda can leverage IAM to securely call AppSync internally. Same as before, AppSync would then perform authorization checks and execute any business logic defined in the resolver. Then send a request to DynamoDB to create an item in the table. And again, same as before, after the data is saved to the data source, AppSync automatically broadcasts the data to all connected subscribed clients. As you notice, AppSync needs to be aware of a mutation in order to send subscriptions data. What if there's an out-of-band process updating DynamoDB in the backend without sending a mutation to AppSync? In that case, AppSync is not aware of the mutation and will not send data to subscribed clients. If there's a requirement all changes to DynamoDB, even out of band, need to be pushed to connected clients, we can leverage DynamoDB streams, invoking a Lambda function that issues a mutation to AppSync. So we're not saving data twice or overwriting the data previously saved on Dynamo. We can use a local resolver for the mutation triggered by Lambda. Local resolvers are internal to AppSync and can work as a pub/sub channel where no data is persisted. Clients subscribed to the mutation linked to the local resolver are then notified about the out-of-band changes in the DynamoDB table and receive the required data automatically. AppSync empowers real-time collaboration with simplicity. Real-time data, connection management, scalability, fan-out, and broadcasting are all handled by AppSync, allowing you to focus on your application business use cases and requirements instead of dealing with the complex infrastructure to manage WebSocket connections at scale. You can visualize metrics on CloudWatch, on active connections and subscription status, errors, message size, and more. You can get started with real-time in AppSync in minutes with a simple generic WebSocket pub/sub API use case. You don't even need to know GraphQL. You can get started by simply creating the concept of a channel that has two properties, a name and a data field with few lines of code using the AWS CDK. Data is sent to a specific channel name. Clients subscribe to the channel, receive the data automatically. In this example, it's all TypeScript. The actual GraphQL schema is generated programmatically. After deploying the AppSync API, you can use the Amplify libraries to generate all the necessary GraphQL operations and client code automatically. It's not even necessary to have an Amplify CLI project. You just need to execute a single command, which is called Amplify Code Gen. We're just effectively using the Amplify client libraries as a real-time SDK for AppSync. Amplify clients provide simple abstractions to interact with AppSync GraphQL API backends with few lines of code, including built-in WebSocket capabilities fully compatible with the AppSync WebSocket real-time protocol out of the box. In this implementation, data is not persisted anywhere. Channels are ephemeral, and AppSync uses local resolvers to publish data to subscribers. In case you just need to implement a real-time feature in an existing application, this generic pub/sub API setup can be easily integrated to any application or API technology. While there are advantages in using a single API endpoint to securely access, manipulate, and combine data from one or more data sources with GraphQL, there's no need to convert or rebuild an existing REST-based application from scratch in order to take advantage of AppSync's real-time capabilities. For instance, you could have an existing CRUD, create, read, update, delete workload in a separate API endpoint with clients sending and receiving messages or events from the existing application to the generic pub/sub API for real-time and pub/sub purposes only. Best of all, this is all completely serverless. It scales automatically with demand, and you only pay for what you use, no infrastructure to manage. You can find the actual code in an article going through the end-to-end implementation by following these links here. But only if you're curious and want to know a little bit more on how the backend is implemented. You can go to the AppSync console and deploy the exact same setup and have a simple serverless pub/sub WebSocket API even quicker. Similar to what CDK was doing in the previous slide, the console wizard generates and deploys a CloudFormation template you can reuse or modify. Then, similar to the Amplify Code Gen command, the console also generates all the configuration and client code for JavaScript, iOS, Android clients with a click of a button. All you need to do is focus on your client code and real-time business logic. Also, based on the simple PubSub API setup I mentioned in the previous slide, there's a small tweak that can be made to turn it into a global multi-region serverless WebSocket API. You just need to add one extra AWS service to the mix, Amazon Event Bridge. The whole implementation is both serverless and functionless. You don't need to add any Lambda functions or any client code there, or any backend code, sorry. Clients are subscribed to a specific channel, and messages are pushed automatically to clients listening or subscribed to the channel in both regions. You can check out details in the GitHub repository link below. So now we are all experts in GraphQL, AppSync, and serverless real-time subscriptions. Let's talk about our shiny new filtering capabilities. There are specific use cases we can't have all clients receiving the same data in a broadcast. We might just need groups of clients or users to receive specific data. Maybe a subset of users is interested in a specific subject matter, while other users have no interest to get data about it. It's important to have a proper filtering solution so specific groups of users only get updates or notifications that are pertinent to them, depending on the set of conditions, arguments, or filters. In the same sense, this should be done one-on-one as well. So only one client receives subscription data. Think of a chat app where one-on-one conversations are private and only the two users in the chat can receive messages. There are two options when it comes to real-time data filtering in AppSync: basic filtering and enhanced filtering. Let's start with basic filtering. So basically, with basic filtering, you don't need to do anything on the backend side. The subscription just needs to be defined in the GraphQL schema and linked to one or more mutations. All you need to do is define argument values on the client side, which means, for instance, AppSync can send data only to clients listening for a particular ID, like a chat ID or a group ID or order ID or user ID, or all of them together. There's a limit of 5 arguments based on strict equality, which means the order of arguments matter. And those arguments, they can be combined with AND logic only. So events from the location X and date Y and description Z, allowing for some flexibility when filtering data to subscribe clients. Basic filtering has been available in AppSync since the service was launched. However, customers told us they want to do more and have complex filtering capabilities. In order to address more complex use cases, we recently launched enhanced filtering. With the new enhanced filtering capabilities, you have more flexibility to decide what clients, users, or devices receive messages based on specific conditions. There are 12 new logical operators to choose from, enabling you to define fine-grained filters for any use case. Filters are defined directly in the subscription resolver in AppSync in a simple JSON format, or directly into the serverless API layer in a central location for all connected clients. Clients can also send a filter payload that allows to have dynamic filters in case there's a requirement for clients to define their own filtering logic. Enhanced filtering in AppSync also enables subscription invalidation capabilities, allowing to define a filter to specifically close WebSocket connections based on certain conditions. These new capabilities simplify application development with improved authorization logic over data. Now let's take a look at the filtering syntax. As I mentioned before, filters are all defined with a simple JSON syntax. A filter group defines a list or group of filters. Filters can have one or more rules, each one with fields, operators, and values. You can use any field defined in the GraphQL schema, which is published by a mutation. In the following example, multiple rules in a filter are evaluated with an AND logic, and multiple filters in a filter group with OR logic. Imagine a ticket management API. In this case, important tickets are automatically pushed to subscribe API clients if a ticket is created with either high or medium priority and severity 7 or higher, or classified as security tickets assigned to either the admin or the operators group. Lower priority tickets can still be manually queried. However, newly created tickets will be filtered in the backend and won't be pushed in real time to clients subscribed to the specific subscription that has the filter defined. With subscriptions invalidation, AppSync can automatically unsubscribe clients from the server side based on an event triggered by a GraphQL mutation and a specific invalidation filter, effectively closing a given WebSocket connection. Invalidation provides more control over WebSocket connections from the GraphQL API backend. Pub/sub invalidation AppSync can be configured with a few steps. In AppSync, we define a new mutation with the specific objective to invalidate and close WebSocket connections. In the mutation resolver, we define the subscription that needs to be invalidated and a payload. The payload is used as a trigger or argument that should be matched with an invalidation filter. We define the next steps. In this case, we use an email address. In the subscription, we define a last step, in this case, onCreated message. We configure an invalidation filter. Let's imagine we have an API that's authorized either by OpenID Connect or Cognito user pools. Clients send a JWT token to authorize a connection from a given user, and AppSync is aware of different user claims or attributes for that specific connection, as they are provided in the JWT token itself. In this case, there's an email claim for that specific connection that can be verified by AppSync. And that's pretty much it. We're all set. A user or a backend service with appropriate privileges can then issue the mutation to invalidate those connections. In this case, a mutation called unsubscribe. You can easily configure any operation in AppSync to be associated with a specific authorization mode. In this case, we can set up the mutation so it can only be invoked if the user is part of admin group. So here we want the user with an email jdo@mymail.com to be unsubscribed. Imagine the user left the company or left a specific group, maybe in a chat, and we don't want JDO to receive any messages anymore. AppSync identifies all authorized connections from the user. Maybe he was logged in with his iPad, iPhone, and laptop, and had subscriptions pushing messages or updates to all 3 devices. After the invalidation call based on the unsubscribe mutation, all 3 devices are invalidated and won't receive new messages with that specific chat group as destination, for instance. Without these capabilities, clients needed to either be aware of certain backend events. For instance, the user was removed from a group chat, or a user was unfollowed by his followers in a social media app. Then the client will need to respond to these events by closing the WebSocket connection with additional client logic and client code. So now AppSync takes care of all of that for you. You don't need to add that logic to clients anymore. So we recommend that you treat mutations used to invalidate subscription connections as administrative operations in your API and scope permissions accordingly by limiting their use to an admin user or group or a backend service. For instance, using schema authorization directives, so the invalidation mutation could only be authorized with IAM, for instance. AppSync supports multiple authorization modes in a single API out of the box, so you can have clients subscribed with API keys and, for instance, backend services using IAM or Lambda to authorize their calls. So before we discuss a scenario where an admin user invalidates connections. However, we can have a backend service invoking the mutation to unsubscribe specific connections that match an invalidation filter. Maybe a Lambda function listens to an event bridge event buzz assuming an IAM role to call AppSync. In this case, no clients can invalidate other clients. Just the specific backend service can do that. So all connections are invalidated. Imagine, for instance, it's a sports game where you want to unsubscribe all clients whenever the actual game ends. So there's no more game stats updates flowing in their WebSocket connections after the match, and you can save on costs. So we took a look at the new filtering and invalidation capabilities. Let's take a quick look at actually how some of our customers are using real-time and AppSync at scale in production. Customers like Sky in Italy use AppSync to provide live sports updates to viewers and fans. Sky was undergoing a migration from on-prem to the cloud, and one of their main goals was to provide faster data. When you're following your soccer team, your Grand Prix motorcycle racing, or your Formula One season, you want the latest updates. After deploying the first web components on its new serverless architecture, they noticed AppSync decreased time needed to propagate data by a factor of 15. It used to take a few minutes to push a full day's update with multiple match scores. The process now takes milliseconds. With AppSync, Sky maintains consistent data performance at peak and off-peak times and pay only for the compute resources it uses, with an estimated of 30% cost reduction. ProSieben-Sat1 and the 7-One Entertainment Group, they are German digital and media companies and offer viewers entertainment content across a variety of media technologies. The previous viewer engagement solution was an on-premise solution that was difficult to scale and required hours of pre-show preparation to support an interactive audience experience during large television events. By migrating to a serverless solution based on AppSync, they reduced its cost by 60% compared to the previous on-prem solution, increased scalability during peak times, and saved hours of pre-show preparation time for upcoming large events by completely removing the need for tasks like pre-warming instances. The migration to use AppSync took 6 months with no downtime or scalability issues. During the finale of a popular singing contest, they experienced some of the highest peaks in traffic that the company had ever seen. About 1 minute after the finale began airing, the system needed to scale by a factor of 10 or more. They saw latency values decline to 13 milliseconds during the peak of requests, which is about 35% less than the typical latency in the previous system. App Health provides intelligent monitoring, staff, and asset tracking in healthcare. They offer a cloud-based tracking solution with radar sensors placed in rooms to monitor and update electronic health records with patient movements such as falls and the presence of staff and other visitors without the use of body-worn sensors. They integrate an IoT backend with AppSync to deliver up-to-date data to their application web interface, which uses real-time location information to provide hospital staff with a live blue dot experience similar to that of popular mobile navigation apps. Their HIPAA-compliant solution to track assets, caregivers, and patients is 10 times more accurate than legacy services. 1/3 the cost of competitors, highly secure and scalable, not to mention it was brought from idea to production in only 7 months because they did not need to worry about maintaining infrastructure. Now a retail use case. Neiman Marcus developed Connect, an omni-channel digital selling application to improve their customer interactions and experience. With amplified development tools backed by AppSync GraphQL APIs, they were able to launch the application in less than 4 months ahead of the initial schedule. Using a serverless backend, they reduced development costs by 90%. AppSync helps Neiman Marcus specify which portions of its data should be available in real time with GraphQL subscriptions. Associates can engage with customers and assist them from anywhere, a high-touch selling approach that was not available before. The app also tracks associate key performance indicators as they can view their sales performance in real time. HyperTrack, another one of our customers, provides a live location as a service. AppSync is a core part of streaming hundreds of millions of live location events between apps in real time and allow them to accelerate time to market and increase development velocity, saving months of engineering efforts and reducing operational costs by 30% by relying on a fully managed service. So we talk about real-time and AppSync, our filtering and validation capabilities. We saw how customers are using AppSync at scale in production in different industries for different use cases. Now let's see it in action. So time for a demo. So I have here an API that I deployed in my account. So let's take a look at the API. There we go. So this is my AppSync console, and I have a very simple API here. So it's a tasks API, right? I can create tasks and assign specific data, and the task has owners, title descriptions, priorities, and some fields here where are defined type, right? So again, GraphQL is a strongly typed system. I have also a subscription here where I track high priority engineering tasks. And we leverage AppSync built-in authorization controls. So basically I set up specific groups, right? So only, for instance, the employee and manager group, they can get data about tasks, and everything else needs to be done by the manager group. So updating tasks and things like that. So a very simple schema, and also all we have here is basically a local resolver, a local data source, and a DynamoDB. So all my data is saved to Dynamo. And I also have a specific subscription with a filter, right? So I can have, I define my subscription, and I have a specific filter. So whoever I just want some users that have a specific match with my filter to receive data. So I just want subscribed users to receive data if they have the task is created with high priority, or the classification is higher than 7, and only for the engineering department. And that's it. That's my filter, and that's how simple you can create filters. You can have multiple filters in a filter group, and you can add more operators like in, contains, greater than, greater, less than, and things like that. So let's first of all test our capabilities here. So I need to log in with user pool. So I have a user that's called Jane, and she's a manager. So she can actually create tasks. So yeah, I'm logged in with Jane here. So let me go to another. So there we go. I'm going to log in with Joe. Joe is an employee, so he can receive tasks and he can be subscribed, right? So here I'm going to subscribe to that subscription I created, and that's very handy in the AppSync console. Pretty much open the WebSocket connection, and you can basically test your subscriptions here out of the box with just creating a subscription query and testing it. So let me test with a new mutation here. So again, I'm logging in with Jane, and I'm going to use to create a mutation. So this is a low priority task. So it should be filtered by my filter, right? So it pretty much it won't send any data to anyone because, for instance, I'm looking for engineering department tasks that have a higher priority here. That's a low priority task, and classification higher than 7. So I can send this. Again, I create my task on my DynamoDB table. Everything is created. But you notice my user here, my user JDO, didn't get any data. So it didn't get any information. It was filtered, successfully filtered on the AppSync backend. And let's just imagine now I have a high priority task, and I want Joe to receive the data, because now this is a high priority task now. So priority high, department engineering, and the classification is 8. So it fits our filtering. So if I send, so this is the result from the previous low priority task. Let's send another request to create a high priority task. There you go. And you notice Joe just, that the subscription filter was matched and received the data accordingly. Now let's test our invalidation capabilities. And I'm going to maybe duplicate this here. And send another subscription. So I want Joe to be subscribed to clients. Imagine maybe he has an iPad and he has his laptop on the other side. So they're going to be subscribed to two different clients, right? And again, it's waiting. It received data from the previous mutation. He's waiting for the next one. So let's take a look at this, our unsubscribe mutation. So that mutation now defines, okay, I want to be linked to that specific subscription that we executed before, and I want to send an email. So the email is going to be the payload. If the email matches that connection, so AppSync keeps track of the context of a connection, and that context of a connection has, for instance, the JWT tokens that have an email claim. So this is pretty much redefined in the mutation. And that exact same subscription we had before, we just added at the bottom, we have that actual subscription filter. We added an invalidation filter. Just if I get the email claim from a JWT token that matches the email sent in my mutation, then just unsubscribe everyone. So let's test that now. I just want to make this easier. Let's just use the Explorer and subscribe. And my JDO user email is jdo@myemail.com. So again, here I have my user JDO. He's subscribed to 2 different clients. So let's unsubscribe JDO now from both of those clients. Again, the mutation was successful. And if you notice here, the clients are completely unsubscribed. You don't see the spinning wheel here anymore. I can resubscribe just by clicking this. I'm creating another WebSocket connection, but basically I close all connections from JDO. Imagine that he left the company or he left the engineering team. But that's pretty much it for our demo. Let's go back to our slides. Just in case, if you also want to test on your own time, so that's a little bit of a fun demo, but you can basically go to our repository and deploy this in your account in about 5 minutes. It uses Amplify hosting if you want to use it, or you can test locally. But you have a really fun real-time canvas. You can basically draw and have multiple clients receiving whatever you're drawing on one of the clients. And it works exactly as animation here. Feel free to give it a try for yourself. So that's pretty much it from our presentation today. So I hope we are able to successfully explain how AppSync can help you in your next development project. With AppSync, you can start effortlessly with your GraphQL journey on AWS, scales with your business, and you just pay for what you use. It provides powerful built-in real-time capabilities, allowing you to unify and secure access to multiple data sources, APIs, and services. Here you have some more interesting links. So you can take a look at our launch blog where we talked about enhanced filtering. That demo that I just showed you is pretty much detailed in the blog. You can run it and create it following all the steps in the tutorial there. You have developer resources where you can find workshops, tutorials, guides, videos. The case studies where we talk about some of our customers, we can actually read them in this link here. We also have a central location where you can access all AppSync related blogs. Just go to AppSync/blog and you can have everything there. Also, serverless land patterns where you can basically deploy interesting serverless patterns with AppSync, and our GraphQL decision guide. Thank you very much. I hope this is useful, and if we have time for some questions, we can address those. Thank you very much.